Right. Definition, right? The force which opposes motion or tendency of motion or tendency of motion is called friction. It's called friction, right? Based on the opposition force, based on the opposition force, friction is derived in two categories. Friction is derived in two categories. Right. Just write one difference. There's two categories. One is dry friction, right? One is dry friction, another one is wet friction, right? Dry friction and wet friction, correct? What is meant by dry friction, right? What is meant by dry friction, students? Just write. Phenomenon exists, the dry friction phenomenon exists due to the irregularities of surface in contact. Irregularities of surface in contact, right? And wet friction is due to, wet friction is due to the continuous collision of medium particles on the body. Due to the continuous collision of medium particles. Any medium, it may be air, water, right? Medium particles on body. Friends, for example, you have seen air friction, right? We say air friction when something moves in the air. So air resistance, we say that. What is that? That is air friction only, right? And you know, in water, in your early classes, you have learned about drag. Fluid friction is known as drag, right? When a body moves water, then also it gets some opposition due to the molecular configuration of water. Yes or no? Those type basically known as wet friction, right? But here we will deal with the irregularities concept, right? Here we will be strictly dealing with the dry friction, that is friction due to the roughness of the surface, right? Give heading dry friction. Dry friction is friction due to the roughness of surface, right? Friction due to the roughness of surface, right? Friction due to the roughness of surface. Correct? Yes or no, students? What is meant by roughness of the surface? Students, say, this is ground, right? This is the ground, and I have kept a body on the ground, correct? Yes or no? I have kept a body having mass on the ground. So here, this is the point of contact, yes or no? That I have made the circle, there is the point of contact, right? Yes or no? If I will zoom this, अगर मैं इसको जूम किया थोड़ा, तो मुझे ये देखेगा कि ऊपर में क्या है? ऊपर में बॉडी है, नीचे पे क्या है? ग्राउंड है, राइट? बॉडी जो प्लेन दिख रहा है उस पे भी कुछ इरेगुलरिटीज है, और ग्राउंड जो प्लेन दिख रहा है उसमें भी कुछ इरेगुलरिटीज है, राइट स्टूडेंट्स? ड्यू टू दैट इरेगुलरिटीज द इंटरलॉकिंग इज डेवलप्ड बिटवीन देम. Able to understand or not? Manish, Purab, Suraj,
Yes.
every nothing is plain, right? Let you are writing something in the pen. That means in the paper there is some irregularities. So in that irregularities, the ink is going and particularly staying on. Yes or no? That's why you're able to write, right? Yes or no? If I'll give you to write on a glass, so can you write? Because irregularities is there in the glass also, but that irregularities is not sufficient enough to hold the ink. Yes or no? Getting my point?
Yes.
Irregularities friction की main cause जो है, that is the irregularities in the bodies get interlocked. When two bodies come in contact, there are certain irregularities in the two body and they get contact. Getting? Yes or no?
Yes.
So interlocking has developed, and that interlocking, let the body wants to go in this direction, but the ground is will not let it to go in the forward direction, right? So that's why we say that the interlocking, we say friction is due to the roughness of the surface, right? And we can also say due to roughness and irregularities, you can write here due to, just write due to roughness, due to roughness and irregularities, correct? On surfaces on contact, on surfaces on contact, interlocks are developed, right? Interlocks are developed, right? Correct. Interlocks are developed, which opposes relative motion between the two surfaces, which opposes, right? Which opposes the relative motion, which opposes the relative motion between the two surfaces. Students got a brief idea of what is the physical significance, what happens physically, so that the friction gets into being, yes or no? Understood? It's due to their interlocking. In this two irregularities, they got interlocked, yes or no? And due to the interlocking at various points of contact, the contact force will be there or not? And the contact force will be distributed in various directions over the surface, right? Then the second point, just write due to these interlocks, due to the interlocks at various points, due to these interlocks at various points of contact, the contact forces are distributed. I'll show you how it happens. The contact forces, right? The contact forces are distributed. Suraj, getting or not?
Yes.
In various directions. In various directions, right? Over the surface. In various directions over the surfaces. Students, how that happens, let's see. You see, like this is the irregularities, right? And here is also some irregularities, like this, some irregularities. It doesn't mean that always the irregularities will be uniform and they will be in exactly, they will be interlocking. Yes or no? Getting my point or not? What is the roughness of the surface? That will be not in the same manner on the ground. Getting my point or not? This was the ground. Student listening now? This was body. Do you think
Yes.
the irregularities will be similar in case of the body and the ground? No, their atomic configuration is different, right? Subham, listening or not? Amrit,
Yes, sir.
Pura,
Yes, sir.
Srishti, are you listening? See here. Student, at this point, there is a contact. There is contact means always contact force will be perpendicular or not? Yes or no? If this is the contact point, see, if this is the contact point, then this will be the contact force. In the same direction, it will giving another contact force. They're equal in magnitude and opposite in direction. Yes or no? If exactly this point is shooting, the normal force will be here, N2, right? N2 will be downward direction here. Sometimes the contact force may be like this, perpendicular to the surface, N3. All getting or not? If every point the particle is in the ground is touching to that body, yes or no, students? Then there will be contact force or not? Just say me. Suraj, getting?
Yes, sir.
What happens finally? If I'll be resolving this contact forces, it will be having two components or not?
Yes.
If I'm going to resolve this one, this will be having two components, yes or no? Getting, students? There will be a vertical component, there will be a horizontal component, right?
Yes.
And all the vertical component, if I'll be adding all the vertical components, all the vertical component will be balanced by the weight mg. Getting my point, students? Yes or no? Getting or not? Students?
Excuse me, sir.
Cool.
सर जो पॉइंट अपन नहीं ना सर इरेगुलर सरफेस दे रहा है सर पॉइंट सर नहीं
Pointer ne became the every where the every irregularities of the body is touching somehow to the irregularities of the ground, right? When there is a touchness, when there is a contact, there will be normal force or not?
Yes, sir.
And it doesn't mean that always the normal force, and the normal force is always perpendicular to the surface, right? And if somehow, if some cases it is not perpendicular, then it will be having two components. One is vertical component and one is horizontal component, right?
Yes.
And all the vertical component, if I'll be mixing all the N1, N2, N3, all the vertical component, they will be balanced by what? Mg, right?
Yes.
And all the horizontal components will give rise to the friction. Understood, Suraj, Manish?
Yes.
Understood? Because if I'll be giving the force in this direction, then it will be opposing to the opposite direction. Yes or no? And student, friction is the cumulative effect of the horizontal components of all the contact forces, right? This is the very important point just right here. I just wanted to show you, right? Friction is the cumulative effect. Friction is the cumulative effect of horizontal components, right? Cumulative effect of the horizontal components of all contact forces, correct? Between the surface. Between the surfaces. Understood? Means this is not actually, this is the thing. When friction comes into being, it should come to your mind that there are irregularities, there are interlockings, and due to the interlockings, there are every contact point, and in the every contact point, there are contact forces, right? And the contact forces will be having some components that will be horizontal and there will be vertical. And the vertical component will be balanced by the weight, and all the horizontal components will give rise to friction. Got a little idea, students, about what physically happens so that friction comes into being, right?
Yes.
Understood or not all? Understood?
Yes, sir.
Okay. So we'll go to next. That means let I have kept a body over here, right? Let I have kept a body over here, correct? And this is the normal force. This is N. And this is the frictional force. No, sorry, this is the applied force. So if the body, if you try to push the body in the direction of applied force F applied, then the friction will be acting opposite direction, right? On that, yes or no? So the ground will not let the body to move. So force of friction will be in opposite direction. Getting, students? Getting or not? So if I'll be making the resultant of everything, that means if at this point of contact, if I'll be drawing the free body diagram, see the normal force will be in upward direction, right? And the force of friction will be in this direction, correct? So net contact force will be in which direction? This direction or not? This is R. Getting, students? This is frictional force. This is normal force. The resultant will be in this direction. Yes or no? So this is the net contact force between the body and the ground. Getting or not? Suraj,
Yes.
this is the net contact force between the body and ground, right? Understood now?
So if is the code.
If applied, I'm giving some force. So the body, the friction is opposite, always opposite to that, to the direction of the applied force, right?
Yes.
And there are two contact force. One is the normal force N, and another the force of friction, right? In this direction, F, force of friction. So the net is the R. Yes or no? Understood, students? This is the very basic thing of friction. All got or not, Sevi?
Yes.
Okay. Next, let's go to types of friction between surfaces in contact, right? Give heading. Types of friction. Types of friction. Keep on writing. If you're not able to write, then leave the in between the lines. You'll update the notes later, right? Types of friction between two surfaces in contact. Between two surfaces in contact. After completion of this friction, I'll come to the Newton's laws of motion, that NCERT part. Okay, what we have learned, what questions we should do, right? Everything I'll discuss after that. Let's complete friction first. These are types of friction between two surfaces in contact. Give heading. Types of friction. When two bodies comes in contact, then what types of friction? What are the different types of friction, right? Students, when two surfaces are in contact, right? Just write, student, just a minute. Let's see. When two surfaces are in contact, the friction between these surfaces can be classified into three categories, right? Number one, right, students? Static friction. Number one, right? Static friction. Correct. That means it acts when the body is at rest, right? It acts when body is at rest. Correct. Yes or no? Number two, limiting friction. I'll explain with example. Limiting friction, right? That is maximum value of static friction, right? That is maximum value of static friction. That is maximum value of static friction, right? Next, number three, right? Kinetic friction, correct? Number three, right? Kinetic friction. That is when body is in motion, right? Okay. So we'll start with static friction, correct? Just give heading, static friction. We'll start with static friction, correct? We'll start with static friction, right? So static friction is what, students? Body is at rest and some external force is acting on it. Static force means body is at rest. Body is at rest and some external force is acting on it. Some external force is acting on it. Some external force is acting on it. Understood, students? Yes or no? Some external force is acting on it. That means what does this important? What is the important of that? Students, I have kept a body here M and the body is at rest, correct? But here, and the ground is rough also. It doesn't mean that it's free and smooth. Interlocking is there, irregularity is there, but I have not given any force. So they are just normal contact force, right? There will be no friction will be not there as long as I have not given. So force of friction is equal to 0 here. No friction. Getting, students?
Yes.
Getting or not? But friction will come into being the moment I will start giving the force, right? This is the body kept on the ground. I have given some applied force to it. Exactly at the same point, some friction will be coming into picture, right? In this case, the body is still at rest. I'm giving it some force. Still the body is at rest. So that means force of friction is equal to directly F applied here, right? Getting or not, students? And that friction is known as what? Static friction. That friction is known as what? Static friction. Suraj, Manish, getting or not?
Yes.
That is known as static friction, correct? And student, it is not that you will be giving on the force, you will be increasing the force, you will be increasing the force. At a certain point will come, the body will start moving, right? Yes or no?
Yes.
Certain point will come, the body will start moving. So the maximum limit up to which the static friction balances the external force, yes or no? Because after that the friction cannot balance the applied force. The maximum value of the static friction will reach then at that time the body will start moving, right? And that maximum value of static friction is known as what? Limiting friction. Is my point, students? So
Yes.
maximum limit up to which, right? Maximum limit up to which the static friction balances right, the external force acting on the body balances the external force acting on the body external force acting on the body is termed as limiting friction, is termed as, right, is termed as limiting friction, is termed as limiting friction, right? Is termed as limiting friction. That we signify, that we write as limiting friction, let FL, right? Fs is static friction. And just after that body will start moving. You have reached limiting friction means body will start moving. Body will start moving. Getting, students? That means when body will start moving, when force of friction, applied force, is greater than or just equal to the limiting friction. Getting, students, or not? Students, getting the point or not?
Yes.
Just note it. Right. Student, it's all theory. Let's know about the magnitude of the limiting friction, right? Magnitude of limiting friction, right? Magnitude of limiting friction, correct? Let's know about the magnitude of limiting friction, right? Student, magnitude depends on, right? Magnitude depends on, the magnitude depends on, right? Number one, normal reaction between the surface and nature of roughness, right? It depends on normal reaction. It depends on the normal reaction between the surfaces correct, and nature of roughness, right? And nature of roughness, correct? And nature of roughness. ठीक है स्टूडेंट्स, इसका मतलब क्या है? देखो, एक चीज मैं आपको बताता हूं. एक नॉर्मल एम है, नीचे की तरफ एम जी है, राइट? ऊपर की तरफ क्या है? नॉर्मल फोर्स है ना स्टूडेंट्स, करेक्ट? मैंने अभी जब उसी बॉडी के ऊपर और एक बॉडी को प्लेस कर दिया तो नॉर्मल फोर्स बढ़ जाएगा कि नहीं? यस और नो?
Yes.
The normal force will be greater. If normal force is going to be greater, then the interlocking will be stronger in the second case or not? Because वो और थोड़ा अच्छी तरह से चिपक के रहेंगे, right?
Yes.
तो interlocking strong हुआ मतलब friction भी strong होगा कि नहीं? Correct or
Yes.
not? So that's why we usually write force of limiting friction is normal is equal to normal reaction, and it depends on various mechanical cases. Ki what is the value of normal reaction? Always normal reaction is not equal to mg. You have seen sometimes it is also mg cos theta, right? Yes or no?
Yes.
FL proportional to, and we can write FL is equal to mu s into n. क्योंकि जब limiting friction की बात आता है तो it comes under static friction, because limiting friction is the maximum value of static friction, right? And this mu s is coefficient of friction, right? मैं एक चीज को हर अलग अलग जगह पे रख रहा हूँ, थोड़ी ना सेम फ्रिक्शन लगेगा अगर उसका नॉर्मल फोर्स सेम मिल रहा है तो. It depends also on the roughness of the surface ना. So that mu s is coefficient of static friction, coefficient of static friction, correct? That is the coefficient of static friction, right? Depends on the roughness of surface in contact. Depends on roughness of surfaces in contact. Depends on roughness of surfaces in contact, correct? Understood or not, students? Just write this much. The most important thing is, let's know the practical illustration of limiting friction, right? Give heading practical illustration, right? Give heading practical illustrations, right? Practical illustration. What happened? What is meant by practical illustration? Just see that this is the ground and I have kept a body over here whose mass is 5 kg, right? How much is the mass? 5 kg. So it will be having a normal force in the upward direction, right? That is the normal force n. And I have given some force, that is F applied. Let this is F, APP means applied. I have applied some force, but still the body is at rest, right? And here, due to the roughness of the surface, the coefficient of friction mu is equal to, let 0.3, right? Let coefficient of static friction, that is mu s. Mu s is coefficient of static friction, right? Let that is equal to how much? 0.3, correct? So if I'll be saying you to calculate what is the value of limiting friction FL, then you can write, sir, you have just told mu s into n, right? And here in this case, you can see if the body is at rest, then mg is equal to in downward direction and normal reaction is in upward direction, and you can write n is equal to mg, right? So you can write n is equal to mg, correct? You can write here n is equal to mg. That means that is equal to how much? G is like 10, m is 5, so that is how much? 5 into 10, that is 50 Newton, right? Yes or no? So you can write, yes or no, students? You can write FL is equal to mu s into n. So putting mu s is equal to 0.3 and putting 50, then you can write how much? This is 15 Newton. So students, you got the maximum value of limiting friction is 15 Newton, right? You are giving some force, but the body is not moving, right? Let's take some example of applied force. F applied, yes or no? Here is F applied I will be taking, and in this part I will be writing F applied, and here we will be writing force of static friction, right? Here we will be writing force of static friction, right? F static. Students, I gave 5 Newton force. Will the body move? No, because the maximum value of static friction is 15 Newton. As long as you have not given 15 Newton force, the body will not move, right? So this is the maximum value of static friction, that is limiting friction, correct? So if you are giving 5 Newton, then that 5 Newton will go to static friction. The static friction is F 5 Newton, right? As I told, if the body is simply kept, I just told you before, if the body is simply kept and I am not giving any applied force, then the net friction is 0, right? So if I will be giving some applied force, that applied force will be converting into what? Friction, right? So I've given here force applied 5 Newton, then force of static friction will be 5 Newton. Let I give here next let I give here 10 Newton. So the static friction will be 10 Newton, correct? I gave here 14.99 Newton. So the static friction will be 14.99 Newton, right? But exactly the moment I will be giving the friction, that is F force applied is equal to 15 Newton. So the body will start moving, right? So at that time, the limiting friction is equal to 15 Newton. So that will be the maximum value of static friction and the body will start moving, students. Understood?
Yes.
Yes.
And all these 5 Newton from 0 to 14.99 or 15, all are coming under static friction, right? And once the body starts moving, then the friction will be calculated in not in this manner. There will be some kinetic friction, as we told. When the body moves, then that friction is known as kinetic friction, right? There the coefficient of friction will be different. Friends, see, once the body starts moving at 15 Newton, right? So this 15 Newton from here onwards, the process to find the friction will be kinetic friction, that is Fk, right? Then once the body starts moving, right, then the kinetic friction comes into being, right? Here kinetic friction. We'll learn now what is kinetic friction once the body starts moving. And as long as we have not reached the limiting friction, any applied force that is given to the body goes to the static friction, correct? Understood that? Then write kinetic friction, students. Then write kinetic friction, right? Kinetic friction. Just write kinetic friction is what, students? It is acts when the body is in motion, right? It acts when the body is in motion, right? It acts when the body is in motion, correct? When the body is in motion, understood? It acts when the body is in motion, right? So student, if the body is in motion, see here, once the body started moving, normal reaction is there. So body is moving, let in this direction, it is moving with some force. So the kinetic friction will be in this direction, Fk, right? And that Fk is equal to how much? Mu k. Because the coefficient of friction for the same surface, it may be for the surface is same, but when the body was at rest, at that time the coefficient of static friction, and the body when it started moving, at that time the kinetic friction, coefficient of kinetic friction will be changing, right? So this is kinetic friction, Fk is kinetic friction, right? Fk is kinetic friction, and this mu k is coefficient of kinetic friction, right? Coefficient of kinetic friction. And this is normal reaction. Students, always one thing you remember, just mu k is always less than static friction, coefficient of static friction, and definitely kinetic friction is also less than coefficient of static or limiting friction. It is also less than the limiting friction, because coefficient of kinetic friction, Fk, is always less than limiting friction. If Fk is less, so student, mu k is going to be less. Why? Because if someone will ask what makes the limiting friction, or sorry, the static friction and the kinetic friction, just keep in mind, students, I'll be keeping this surface in contact, right? I am keeping surfaces in contact means the molecular of each, the molecules of the body, the molecules of the surface or the ground, they're having some molecular attraction, right? Chemical bonding chapter, you will be learning that. In that molecular attraction, they're actually getting an attractive force, and I'm trying to that break the bond and move the body on that, right? And when you will be giving some time, because static friction means the body is at rest. So if the body is at rest, the two bodies are getting some time. Two bodies means the molecule of the two bodies are getting some time to make the bonding strong, correct? But once the body start moving, then the two molecules will not get sufficient time to make their bond strong, right? Two friends, they're coming in contact always. They're everyday meeting, they're the same tuition, same place they're going, so their bonding will be a little bit tough, right? But you are not meeting anywhere, somehow you are meeting sometimes, so your bonding will be a little less. The same things also molecules. I will just take the molecules and keep them close, so the bonding force will be little more, right? But if the body moves, then the body will not get time to make the bond, right? So that's the reason the kinetic friction is always less than that of the limiting friction, right? And student, kinetic friction doesn't depend on the applied force, right? How much force I'm applying, that doesn't that is not going to decide what is the kinetic. It simply depends on normal reaction and what is coefficient of kinetic friction, right? So just write it. और स्टूडेंट बॉडी मूव कर रहा है, मतलब बॉडी ने इंटरलॉक को ओवरकम कर लिया, राइट? तो लेस इंटरलॉकिंग होगा वहां पर। जब खड़ा है तो जितना ज्यादा अच्छी तरह से चिपक के रहेगा वो इंटरलॉकिंग होगा, बंडिंग होगा, बट जब मूव करेगा तो इंटरलॉकिंग थोड़ा कम हो जाएगा, इंटरलॉक्स इरेगुलरिटीज रहेगा, बट इंटरलॉकिंग के पास जाने के लिए मौका ही उसको नहीं मिलेगा, विल नॉट गिव दैट मच टाइम व्हेन द बॉडी स्टार्ट्स मूविंग टू गेट द इंटरलॉकिंग स्ट्रॉन्गर, राइट? सो लेस इंटरलॉकिंग विल बी देयर. So this is all about the theory of static friction, kinetic friction. Yes or no? Tomorrow onwards we are going to do the numericals of this, right? Just to read these theories and everything properly, right?